Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, afternoon, evening. So this is basically a tutorial by request given by one of your friends. Okay, so we have here a shaded area. Okay, shaded area. This is our shaded area. It's bounded by two curves with the corresponding equation as shown. Okay, so we're given the two equations. This is the first equation. This is the second equation. So all the units are in meter. Okay, great. So the first part asks us to find the centroid of the shaded area and clearly indicate the element and the equations that are used, and we have to express the answer with a coordinate system. Coordinates, right? And then the second part wants us to determine the moment of inertia about the x-axis of the shaded area. That means they want us to find the ix, okay? And the first question, obviously, they want to find what is x bar and what is y bar, okay? So how do we proceed with this problem? So first and foremost, for part A, we can actually section the element either by using a vertical element, okay, or a horizontal element, okay. So for this question, if let's say we were to use a vertical element, okay, let's say we do vertical element, it may seem like it's a good choice, but you might run into a problem, okay. And what is this problem is that you'll have to section your area into two regions. Okay, the section area into two regions. So here I'll call this as region 1, and this one I'll call as region 2. Why is that the case? Because the first section, your x is only bounded by the x-axis and this equation, whereas your second region, you're bounded by both this equation and this equation. So that's why you need to split to two regions, and you have to do the computation, which is going to be a bit tedious. Whereas if you were to do the horizontal element, okay, so the horizontal element, if you were to do it like this, let me erase and show it to you guys. It would be something like this, okay. I think I use green, I think I'll do better. Okay, so your horizontal element will look something like this, okay. That means that you're integrating respect to dy, right? Vertical is dx. And for horizontal element, the reason why it's actually better is because your length here, okay, you're only being bounded by these two curves, okay. You're not affected by anything else actually, and this will remain consistent throughout all the y values from 0 to 2. Your rectangle here is basically bounded by these two curves. So you don't have to split into two parts. That means that your integration will be far easier, okay. And later, when you have to find moment of inertia about the x-axis, basically it is this vertical element right here that you need to use, okay. So it will be simply the integral of if I'm not mistaken, yes, it will simply be an integral of y square dA. So means it will simply be an integral of y square dA, okay. So for ix, the moment of inertia about the x, if you want to find the integration in really y square dA, we will take the horizontal element in this case, okay. That's why I suggest to go with the horizontal element for both A and both B, okay. It'll make your life so much easier. So without further ado, let's go and solve for both parts. So for A, okay, if you want to use the horizontal element, we need to actually change the equation, we need to change the equation into x equals to a function of y for both parts, okay. So it's x also equals to a function of y, okay, because the thing is, when we're using the horizontal element, we're integrating respect to dy. So definitely these equations you need to express in terms of a function of y, right? X equals to whatever function of y, okay. So for this case, first equation is y equals to 1 over x. Y equals to x to the power 1 over 3, okay. So if I write it in another form. Basically 1/3 is the cube root of x. Therefore x equals to y cubed. This is your first equation. Your second equation is just y equals to x over 2 minus 2. X over 2 minus 2. So you rearrange the equation, you get y plus 2 equals to x over 2. So your x is equals to, you bring the 2 to the other side, becomes 2y plus 4. So you already have your two equations now. That's amazing. Then now, for the element here, which we're going to be using, right, this is going to be dy, right? And if your element is being bounded between the, this is what we're going to call this as the x1 minus x2. So your dA would be x1 minus x2 dy. So what is your x1 and x2? So looking back at our equation right here, okay, I'm going to erase this by the way. If you're looking at the perspective of the y-axis, okay, from the y-axis, which one is the one that's dominating? Is it x equals to 2y plus 4? Or is it x equals to y cubed? Which one is the one dominating? If you were to a little bit look in the perspective of the y-axis, you can see this is on top of this. Okay, so this would be our x1 and this would be our x2. Okay, because if you look at the perspective of the y-axis, you can see this is ahead of this one. So therefore this would be our x1, this would be our x2. So therefore your dA would be 2y plus 4 minus y cubed dy. Okay, so that's your dA. But remember, if you want to find the centroid, which is just simply x bar is just equivalent to the integral of x tilde dA over the integral of dA, right? And your y bar is equals to the integral of y tilde dA over the integral of dA. Okay, so your x tilde and your y tilde, if you guys remember, it's basically the center of the element itself. So this is basically your x tilde and your y tilde. Okay, so if you look actually back in your graph, okay, so what we can see is that the y tilde itself, okay, typically the y tilde is based on what? For each element, the y tilde is affected by your y coordinate value. Your y tilde changes with your y coordinate value. Okay, so therefore you can say your y tilde is just equivalent to 1. Okay, whereas your x tilde on the other hand, your x tilde actually is dependent upon your x1 and your x2. Okay, because it's just basically x1, so this is your x1, okay, and this is your x2. So your x tilde, okay, if I were to draw in a different color, your x tilde is going to be here in the middle. So basically there's x1 plus x2 divided by 2. Okay, so therefore it will just simply be x1 plus x2 divided by 2, which is, 2y plus 4 plus y cubed divided by 2. Okay, so with that being settled, we can easily do our integration. Okay, so I suggest to integrate step by step, so later it'll be easy to substitute in. So meaning to say that let's integrate our dA first. Okay, and we already have our dA expression. This is our expression for dA. So it will just simply be 2y plus 4 minus y cubed dy. Okay, but then we have to put our limits of integration, and our limits are from 0 to 2. So we put here 2 and 0 from the y-axis. Then we do the integration. We get here 2y squared over 2 plus 4y minus y to the power of 4 over 4. And then we substitute our limits 2 and 0. So here you can use your calculator, and then you get your dA as 2 Okay, so let me put my 2, 8. So you get here 8, and then of course you put 0 becomes 0, so therefore you're left with 8 meters squared. Okay, because we are finding the area of the whole thing. Great. So now the next thing we're gonna do is we're gonna also find for y. I'm gonna put the next page actually, by the way. So let's do it like this. So we're gonna find the integral of y tilde dA. So again, the limits are the same as before. It's always 2 and 0. The y tilde in this case was 1. I'll say y on that. Multiply it with your dA. So it's just simply 2y plus 4 minus y cubed with respect to dy. So first you multiply the y to the equation itself, make it easier for you. So it becomes 2y squared plus 4y minus y to the power of 4 dy. Then you perform the integration. So it becomes 2y cubed over 3 plus 4y squared over 2 minus y to the power of 5 over 5. And then you put your limits 2 and 0. Okay. So let's put our equation in the calculator. 4y squared over 2. And then you have here y to the power of 5 over 5. Yes, minus here. This equals to 2. Okay. You get 104 over 15. This is meter cube, by the way. Okay. Yeah, let me just check. Yes. Yeah, the dA was this one. Okay, great. So then we're gonna do for the last one, yeah? That would be, in this case, it would be the integral of tilde x dA. With the same limits you put in. Now x tilde is gonna be a little bit tricky because you have an equation here, so it becomes half times 2y plus 4 plus y cubed. Okay, multiply with 2y plus 4 minus y cubed dy. Okay, so it's half the constant. You can take it out actually, so no problem. You do the integration, you simplify the expression as it is. So 2y times 2y is 4y squared. 2y times 4 becomes 8y minus 2y to the power 4 plus 8y plus 16 minus 4y cubed. The last one is gonna be plus 2y to the power 4 plus 4y cubed minus y to the power 6 dy. Okay, so simplify the expression, so this is half 2 and 0. So let's take the terms. So we have here y to the power negative 6, right? So y to the power negative 6 is going to be here. So negative y to the power 6, sorry, my bad. Okay, then what we see is that negative 2y to the power 4 plus 2y to the power 4. Anything else here? Y to the power 4? No, okay, so this will cancel out. Okay, great. Then we have here 4y squared. Or you see 4y squared once. Okay, interesting. Okay, so 4y squared you just see once only, okay? So I'm just going to write here plus 4y squared. Okay, and then let's see. We see 4y cubed here minus, and we see a plus here, right? Plus 4y cubed. I don't see any of the 4y cubed, so you can just cancel it out safely. And then we have here 8y and 8y. That will make you 16y, so it's going to be plus 16y. And then we have 16 only, right? Plus 16. So yeah, that's about it. So plus 16. dy. So we just do the integration, so it becomes, this half is not a problem, negative 1 to the power 7 over 7 plus 4y cubed over 3 plus 16y squared over 2 plus 16y. Okay, so when you put here 2 and 0, okay, so this half times negative 2 to the power 7 over 7 plus 4 over 3 2 cubed plus 16 over 2 2 squared plus 16 times 2. Okay, so you get here 592 over 21 meter cube. 0 obviously will be 0, so there's no point. Okay, so we've already solved it for x tilde dA, y tilde dA, and dA. Now it becomes very easy. Just simply plug it into the Centroid formula. Okay, over dA. So it's just simply 592 over 21 over dA, which is we computed as 8. So our answer would be 592 over 21 divided by 8. So 74 over 21, okay, meters, which if you convert to decimal places in 3 significant figures would be 3.52 meters. Whereas it's for y tilde, okay, well, so it is 104 over 15 divided by 8. 13 over 15 meters and 0.867 meters. Okay, decimal places, right? 3 decimal figures. So if we look at it, yeah, we get the correct answer, 3.52 and 0.867. So that resonates with our answer clearly. So yeah, there's already your 17 out of 17 marks. Okay, we've already backed this. Now we come to the second part of the question. Okay, part B. So part B, we wanted to find the moment of inertia on the x-axis, that's Ix, right? Which is just simply the integral of y squared dA, where we took the vertical element. So we take the same vertical element as before. Okay, we take the same vertical element as before. Okay, this is our dy, x1 minus x2, right? x1 already we figured out is 2y plus 4. Yes, so it's 2y plus 4. x2 is y cubed. Okay, so if I'm not mistaken, our moment of inertia formula was what? Ix equals to integral of y squared dA. So Ix is just simply the integral of y squared dA. So what is our dA? So our dA is just simply x1 minus x2, so x1 minus x2 dy, which is just simply 2y plus 4 minus y cubed dy. Okay, so we already specified our element. Now we can easily do a moment of inertia, which is just integral of our limits from 2 and 0. We just y square times dA, which is just 2y plus 4 minus y cubed dy. Okay, so simplified expression, you get the 2y cubed plus 4y squared minus y to the power of 5. Yeah. So we do the integration. So what we end up getting is 2y to the power 4 over 4 plus 4y cubed over 3 minus y to the power 6 over 6, 2 and 0. Okay, and we just substitute it in as normal, so it becomes 2 to the power of 2 times 2 to the power 4 over 4 plus 4 over 3, 2 to the power of cube minus 2 to the power of 6 over 6, 8. So here the answer is 8. And since we're doing moment of inertia, yeah, what are the units? So this y here is, y is meter, but y squared becomes meter squared. And since there's an area, dA, that's meter squared. So once you have meter squared, what will happen? You get meter to the power 4. So your unit will be meters to the power 4. That's your final answer. And your marks also will be, I think you get, 8 out of 8. So, yeah. So basically that's the breakdown actually of how we solve for this question. I hope this is actually very helpful. And yeah, any other questions, you let me know. Assalamualaikum warahmatullahi wabarakatuh.